Beep. Okay, so every time you have a quiz, every time you have a test, I will make a review, especially if it's crooked like this. That's stupid. Stop it. Stop being crooked. Kind of better. Okay, so you've already had this. This is the answer key and how I would think about it. The population of Lee's Summit has increased significantly since the year 2010. In fact, the approximate number of people has doubled each year. So if I was a thinker, I would probably underline some things, because when I'm reading a word problem, I want to know what's important. It was reported in 2014 there were 160,000 people in Lee's Summit. Okay, so this is also important. So I've got a couple years, I've got doubled each year, I've got this. So now, what does doubled mean? Well, that means we're multiplying it by itself, or by 2. So we're multiplying it by 2. Okay? So, assuming that the number of people doubles each year for the next 3 years, determine the population in 2015, 2016, and 2017. So I'm going to put 2015 equals, I'm going to put 2016 equals, and I'm going to put 2017 equals. And I'm going to get a calculator because you know what? I don't like to do a big math like this. So, we know that in 2014 is 160. So we have 160,000. And it doubles. Doubles means times 2. So that should give me 320,000 people. Notice how I label. I don't put just 320,000. I put 320,000 people. 2016 now is 320,000 because that's the new population of 2015. And it doubles again. And that gives me 640,000 people. 2017, I've got 640,000, oh my goodness, times 2. And that's going to give me, and now I'm going to use my calculator, times 2, and that gives me 1,280,000 people. Okay? So, that's how we're answering this question. Pause real quick over there, Ella, so I can have my mouse back. So now as we move on, we're going to see this table. And it says, assume the trend in numbers, and actually this is perfect. Ha! Go ahead, Ella, you're good. Assume the trend in numbers, you have to slide it to the left, there you go. Keep going to the left, keep going to the left, there you go. Assume the trend in numbers of users doubling each year was true for all years from 2010 to 2018. Complete the table using year 2014 as year 1 with 160,000 people as the population. So here's year 1, and this was 160,000 people. Well, year 2 is really 2015, and I would write that. I'd write that. And this is going to be 320,000. Year 3 is 2016, right? 2014, 2015, 2016, 2017. This is going to be 640,000. This is 2017, and this is 1,280,000. Oh, year 5 is 2018. Okay, so now I got to get my calculator again, and I'm going to keep it at 1,280,000 times 2, and that gives me 2,560,000. Okay, so now here's the question. We're also trying to go back to 2010. So this is 2013, 2012, 2011, 2010. Well, how are we going backwards? Well, if we were doubling it this way, to go backwards, we have to do the opposite, or the inverse, which is divide. So I'm going to take 160,000 and I'm going to divide it by 2, and that gives me 80,000. I divide it by 2 again, that gives me 40,000. I divide it by 2 again, that gives me 20,000. I divide it by 2 again, that gives me 10,000. This table is the key. This table right here is the key. Questions so far? I hope not, because I can't answer them anyway. So this table is the key. I'm going to erase down here. I'm going to steal my mouse back. Stop messing with my mouse. I'm stealing my mouse back. Okay, go ahead, take it. Now it says, go all the way to the left, keep going to the left, keep going to the left, there you go. Given only the population in 2014 and the assumption that the number doubles, how did you determine the population for years 2, 3, 4, and 5? Well, this was easy. We multiplied the previous year's population by what? Well, if it's doubling, we multiplied it by 2. And I showed you that already on the original example. Letter D, given only the number of users in 2014 and the assumption that the population doubled each year, how did you determine the number of people in Lee Summit for years before that? Well, we divided the year in front by 2. So to go up, we were multiplying by 2. To go backwards, we were dividing it by 2. Questions, concerns on these? Okay. Ella, I'm stealing my mouse back. Are you not done printing these all off, Ella? What? Oh my gosh, Ella. What kind of TA are you? Okay, this is tricky. Go ahead, you can steal the mouse back. Write an equation to represent the population P for year T, which is greater than or equal to -3. So, don't worry about that. We know that P is the population. This is what we're getting. P is going to equal something. Well, what are we doing? We're multiplying each year by whatever year it is. So we're taking T to the first. That's what we get. T to the second. That's how we're going to get all of these. This is the equation to represent the number of users, or the number of population in this. So let's say it was tripling. We would have P equals 3 to the T power. What if it was multiplying it by 5 every year? Well, it would be P equals 5 to the year. Because each year that happens, we have to multiply it again. So now assume the total population continues to double after the year 2018. Determine the number of people in Lee Summit in 2030. Given the population of the world's largest city is 38 million, do you believe your answer makes sense? Explain why or why not. Well, remember where we were at. We were already at 2 million in 2018. Then it's 4 million in 2019. 8 million in 2020. 16 million in 2021. 32 million in 2022. 64 million in 2023. That's bigger than the largest city in the world. So, given the population of the largest city, which is 38 million, do you think that when it keeps doubling, Lee Summit is going to make sense? Well, I'm going to say no. Because Lee's Summit will never be the largest city in the world. And I can add on, it's not even the largest city in Missouri. So it just doesn't make sense. Okay? Sometimes in the math, you can do the math, but it might not always make sense. Questions, concerns? I hope not, because that's all there is. Okay, moving on. Stealing my mouse back. Let's shut this music off. Will you press the mute button at the top of that computer? It's the one that looks like a mute microphone. Thank you. Okay. So, use the property of exponents. Use the property of exponents to write an equivalent expression, which really means simplify. Equivalent means it's going to look different than this, but still have the same value. Well, when I look at this, I have x to the third, y to the fourth, z to the eighth, x, y, z to the third. Well, the first thing that we need to know is everything has an exponent. The x has an exponent. The y has an exponent. Those have to be there. So now, what am I going to do? Well, I'm going to keep the x. I'm going to show that when I'm multiplying like bases, I add the exponents. We keep the base, we add the exponents. We keep the base, we add the exponents. We keep the base, we add the exponents. Is this where I want to be? No, but this is proving it. So if it ever says prove, you're using the properties to prove it. So now I have x to the fourth, y to the fifth, z to the 11th. Okay, that's multiplying like bases, where we keep the base, we add the exponents. Relatively easy. Questions on this one? Again, you can have questions, but it's a video, you can't ask them. Moving on. Ella, are you done?
No, I didn't know.
Oh. So use the properties of exponents to prove the following. Oh, Mr. H, you dog, you have a mouse back. So we're proving that this meets to this. So what I'm going to do is I'm going to rewrite it. I'm going to say, okay, I've got 5x to the third, z to the fourth, parentheses to the 8th. And then I'm going to say, okay, well, what do I need to do? Well, we know that every variable, every number, everything must have an exponent. So I'm going to put the 1 there, and then I'm going to show that I'm taking the exponent and multiplying it to all of the other exponents. And if you're like, well, Mr. H, what is this? This was lesson 3, where it's a power raised to a power. So now I can say, okay, that's 5, 1 times 8, x, 3 times 8, z, 4 times 8, which equals 5 to the 8th, x to the 24th, z to the 32nd. This is proving this. Showing all of that work is proving that. Just go ahead and grab them because you're not going to have time to make copies.
Okay, you just wanted me to do module 1, right?
Lesson, just topic A and B.
Oh, I did C and D too.
Wow. Okay, get all of those.
Okay.
Okay, that's why it took you so long. Okay, questions on letter B. Letter C, use the properties of exponents to write an equivalent expression. Well, for this, there's not a lot of showing. This is division. With division, I always teach my kids, hey, still make the fraction bar. Where is the bigger exponent? The bigger exponent's in the numerator. The bases are the same, so I put my exponent or my variable in the numerator because that exponent's bigger. And then I subtract 24 minus 13. Well, what would be in the denominator? A 1, because really it's dividing out. So now I have z to the 11th, because anything divided by 1 is that anything. So I'm left over with z to the 11th. Moving on. Maybe, yeah. Okay. Let's see if I get a chuckle out of this. Ellie writes 8 to the third times 3 to the fourth equals 24 to the 7th. I got a chuckle, by the way. And the teacher marked it wrong. Explain Ellie's error. Okay. These are not like bases. You cannot add the exponents. Nor can you just multiply the bases together. So Ellie did 2 things wrong. She added exponents for bases that aren't the same. Wrong. Bad Ellie. Ellie also multiplied 8 times 3, which if there were no exponents, we could do. But because there's actually exponents with it, you cannot multiply those until you actually simplify them. So that would be 64 times another 8, I think 216, 9, 27, 81. So you would be multiplying 216 times 81. Let's see if I was right. 8 to the third power. Come on, Mr. H, were you right? 8 to the third power. Oh, no, it's 512. So I'd be multiplying 512 by 81. I wasn't even close. Okay. And I think we have 2 more problems. Nope, last problem. Love it. Find, this is the last problem, yes, Ms. Tucker?
Yeah.
Wonderful. Find n so that the number sentence below is true. I want to press enter a couple times. There we go. Okay, now it's up there where we can see it. So, I've got, and she locked herself out, so don't worry. Ella just locked herself out of the room. It's fine. It's good. Don't worry about it. Now she slammed the door because she's angry. Oh, so angry. So we've got 3 squared times 9 squared. Well, I can't combine these, but 9 squared is 9 times 9, which is really 3 times 3 times 3 times 3. So now we have 3 squared times 3 to the nth. This equals this. Well, why? Because 9 squared, which is 3 times 3 times 3 times 3, what does n have to be? N needs to equal 4. Do you even need to do this? Well, no. You could look at this and say, 2 plus what gives me 6? 4. Or you could draw it out and again say, well, I've got 3 squared times 9 squared. That's 3 times 3 times 9 times 9. Well, I know 9 is 3 times 3 times 3 times 3. And then I could count these 4, these 2, and that's how we're getting n equals 4. I can't wait to see how you do on the first quiz. You have plenty of time to email myself or Miss Tucker or Miss Blair for help. If you don't understand, take a picture of your work, send us an email and say, hey, I don't get it. Can't wait to see you guys crush this quiz.